Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor and today we are solving some questions from A-Level Maths 9709 Pure Mathematics 3 May June 2021 paper 3 variant 3 question number 1 till 6 is already uploaded. So first of all we have question number 7. The topic is differential equations. So for the curve shown in the diagram, the normal to the curve at the point P with coordinates x comma y meets the x-axis at point N. The point M is the foot of the perpendicular from P to the x-axis. The curve is such that for all values of x in the interval x is greater than or equal to 0, less than pi over 2, the area of triangle PMN is equals to 10x. The requirement of part A, part 1 is that show that mn over y is equals to dy over dx. So what we know is that the value of dy over dx will give us the value of the gradient of the tangent at any particular point. So in this case, that point is P. Okay. So the value of dy over dx will give us the value of this straight line, which I've just drawn, which is the tangent to the curve at the point P. And this tangent is perpendicular to the normal. Okay, so we can say that the gradient of tangent multiplied by gradient of normal is equals to -1, and in place of the gradient of tangent I can write dy over dx, and in this case the normal is a straight line Pn, so I've just mentioned that dy over dx multiplied by gradient of the line Pn is equals to -1. Then first of all, what we are going to do, we are going to find the gradient of this straight line Pn. And for that purpose, one point we have is P, which is x comma y, and the other point is point N, which is ON comma 0, because this point N is lying on the x-axis, so the y coordinate is supposed to be equals to 0, and the x coordinate over here is ON. So we can say that the gradient of the straight line Pn is equals to y2 minus y1 over x2 minus x1, 0 minus y divided by On minus x. And in place of x, I can exactly write the value OM. I can just mention that in place of x, we can write OM over here. As simple as that. So minus y over On minus OM. And as we can see that ON minus OM will give you this straight line MN. So I can say that the gradient of this line PN equals minus y over MN. And then we can use the relationship of the perpendicular lines that the product of their gradient is equals to -1. So dy over dx multiplied by minus y over mn will be equals to -1. And now what we need to do, we need to just make dy over dx the subject of the equation. So dy over dx equals minus mn over minus y. Therefore, dy over dx is equals to mn over y. As simple as that. Then part 2 says that hence show that x and y satisfy the differential equation half y square multiplied by dy over dx equals to 10x. Now, as we know, the information is given to us that the area of triangle PMN is equals to 10x. Now, how to find the area of this right angle triangle? It's simple, half into base into height. So half multiplied by mn multiplied by this line PM, or you can say MP. So half multiplied by mn multiplied by pm will be equals to 10x. Now in place of pm, I can just write y, because the length of this line pm, the height of this triangle will be the y coordinate over here, since p is having the coordinates x comma y. And in place of mn, I can use the equation over here, which I have proved, which we have just proved in part A, part 1. Since dy over dx was equals to mn over y, so therefore if you make mn the subject of the equation, this will be equals to y multiplied by dy over dx. So in place of mn, I've just mentioned y multiplied by dy over dx. So half into y into dy over dx into y will be equals to 10x, and eventually you have just shown that half y squared dy over dx is equals to 10x. We have proved this differential equation. Now in the next part, we need to actually solve this equation, given that y is equals to 1 when x is equals to c, when x equals 0. That's my pen. Solve this differential equation to find the equation of the curve expressing y in terms of x. So we have just shown this differential equation, half y square multiplied by dy over dx is equals to 10x. So first of all, what we are going to do, we are going to separate the variables over here. So y square multiplied by dy will be equals to 2 multiplied by 10x multiplied by dx. Now this means that y square will be integrated with respect to y, and 2 is a constant term, and 10x will be integrated with respect to x. So first of all, what I'm going to do is I'm going to do some working for integrating 10x with respect to x. And as you know, the fact that the standard integration of 10x is not given to you in the formula sheet. So I'm just doing some working over here. Integrating 10x with respect to x. So as we know that in place of 10x, we can use the trigonometric identity sin x over cos x. So we are integrating sin x over cos x with respect to x. Now, if the fraction, the integrand, the fraction, which is supposed to be integrated, in this case, we are having a fraction over here, sin x over cos x. If the fraction is itself in the form of f dash x over fx, f dash x over fx. So if you integrate it with respect to x, you will get ln fx and then plus c. So if it is not exactly in this form, and all you need to do is just adjust a constant term. Either you multiply a constant term or you divide a constant term such that it comes exactly in this form. I mean, in order to convert it into this form, all you need to do is just to adjust a constant term. So you can use this integration by recognition method. The integration is the reverse process of differentiating ln fx. Okay, so as we know that fx equals cos x. So f dash x is supposed to be what? F dash x is supposed to be minus sin x. So if this integrand, this fraction which is supposed to be integrated, if this was given to you in this form, minus sin x over cos x. So he would say that, yeah, the integration would be ln cos x and then plus c. But unfortunately, this is not the case over here. What we need to do, we need to get rid of this minus sign. And for that purpose, I'm just going to multiply minus 1 outside. I just need to adjust a constant term by multiplying it or dividing it. So I can say that minus multiplied by the integration of minus sin x with respect, minus multiplied by the integration of minus sin x over cos x with respect to x will give us minus ln cos x and then plus c. So when I'm obviously multiplying minus 1 over here, so minus 1 is also multiplied over here. Now I can say that the integration of sin x over cos x with respect to x is supposed to be minus ln cos x plus c. So you can write it like this as well, or according to the laws of log, our law, this minus 1, the constant term, can be taken in the power over here. So this will be ln cos x raised to the power minus 1, which will be ln 1 over cos x, and which will be eventually ln sec x. You can write that as well. Okay, so when you integrate sin x over cos x with respect to x, you will exactly get minus ln cos x plus. So now we can use this working over here. So on the left hand side, as we can see that we need to integrate y square with respect to y. So this will be y cube over 3. And on the right hand side, we have a constant term 2. This will be multiplied by the integration of 10x with respect to x, which is minus ln cos x. And we need to just add c on any one side of the equation. The usual practice is to add c on the right hand side of the equation. Since we are solving a differential equation over here, you don't need to add c on both sides. Either you add c over here or you add c over here. Okay, so y cube over 3 is equals to minus 2 ln cos x and then plus c. Now the condition over here is given to us that when x equals 0, y is equals to 1. So we need to use this condition in order to find the value of c. When x is equal to 0, so y is equals to 1. So 1 cube over 3 is equals to minus 2 ln cos 0 and then plus c. So 1 over 3 is equals to minus 2 ln. And since you know that the value of cos 0 is equals to 1, so this is minus 2 ln 1 and then plus c. And since ln 1 is equal to 0, so therefore c is equals to 1 over 3 only. Okay, we need to express y in terms of x as well. We need to make y the subject of the equation over here. So far what we have achieved is y cube over 3 equals minus 2 ln cos x minus 2 ln cos x and then plus 1 over 3. So you need to make y the subject over here as well. So first of all, make y cube the subject. So y cube is equals to 3 multiplied by minus 2 ln cos x plus 1 over 3. So y cube equals what? Minus 6 ln cos x plus 1. Or you can write y cube is equals to 1 minus 6 ln cos x. 1 minus 6 ln cos x, and therefore when y is made a subject, so y equals 1 minus 6 ln cos x whole thing raised to the power 1 over 3. Or you can write y is equals to cube root of 1 minus 6 ln cos x. This is supposed to be your final answer to question number 7, part B. Both forms are acceptable.